Welcome to Design Everest TV. Today with me is Mohan Mahal, the CEO of SIDCO, a company based in San Jose. Mohan, welcome to the program. I'm really pleased to have you here. I've been reading before our call about what your company is doing, which is quite interesting. Could you explain a little bit about your work?
Yeah, the company's name is SIDCO Homes Inc. And SIDCO stands for Sustainable, Innovative Design and Construction. The philosophy of starting this company was that we wanted to do something very innovative and we wanted to build homes which are different than what we have been building for the last 400 years, So most of the homes that we build are net zero homes and passive homes, So that's the general trend that we are following to kind of build these homes. Go ahead.
But can you explain what is net zero homes?
So a net zero home is a home which produces more energy than it uses over a period of 1 year. So if the house example is to use 1,000 kilowatts every month, so our home will produce more energy than it uses, So when the house produces more energy, we are basically called a net zero home. But typically, people think of a net zero home that I can have a house which is not very efficient, and I can put like 40 panels on the house and say, hey, my home is producing more energy, and it's a net zero home. But that's a very inefficient net zero home. For the net zero home to be very efficient, we build our homes inspired by the passive design and then make them into net zero. So the passive home design, reduces the energy consumption by almost 80%. So our homes are very well built with insulation and lot of air tightness. So there is no leakage in these homes, and they are very energy efficient windows,
It's quite an interesting concept because at the same time, the efficiency of the energy inside the house, where the energy comes from and where it goes wasted, is always a cycle. So how do you go around these cycles to make it efficient enough that you don't lose energy, other than isolation?
Sure. So typically, a house loses a lot of energy through its roof, through the walls, through the windows, and through the leakage, So what we do in a passive home is we make the homes really, really airtight. We insulate the home really well. We have a R60 rated, insulation up on the roof. Our roofs are usually about 10-inch thick. Similarly, our walls are much thicker than the normal walls, and they're insulated very well. So in every house, most of the energy is used for heating and cooling and water heating. So with this method, we reduce the heating and cooling load by almost 60 to 80% by just insulating the house and making it airtight,
There's a lot of technology innovation happening at the moment that I see it's affecting your part of the market as well. For example, the way the 3D printing is working. How do you use this technology, and do you see applicable use for these kind of things in your field of work?
So, yes, I'm very much aware of the 3D printing. I've seen some of the models being built like that, but I have not seen the application of that coming to US at this point, What we are looking at is we are looking at building homes differently than the way we've been building in the last so many years. Because most of our homes in US are built with lumber, and unfortunately, City of Paradise was completely burnt in 4 hours when there was a big fire over there. So in part of the innovation from our company side, we are exploring and building homes that will withstand fire, will have no issue with termite, will withstand water damage, and will be very well insulated and passive inspired net zero homes. I'm looking at a technology called SIPs, structurally insulated panels. So typically, a structurally insulated panel has, OSB or plywood on the outside of it. But we have made these panels insulated with a layer of MGO or a concrete unit. Now, these panels make it very, very energy efficient, very stable, because every wall is built as if it is a wall, as a shear wall. So this new technology is going to make a very big difference. And a lot of countries in Europe, China, and even India, they've started building with this technology. But it's fairly new to US.
But how about the cost? How does it affect the price of the house, finishing the house?
That's the most important thing. So the good thing is a house construction over here can take up to 1 year, 6 months to 1 year. So it takes a lot of time and labor and material to kind of build these homes. We have to do it on the spot. With this technology, a lot of manufacturing of the panels and the walls and the insulation can be done in a factory. So we cut back the cost of our construction time at least by half. So we pour the foundation, and then all my walls kind of come in, and we erect them within a week. And then we go back and put the rest of the utilities and the kitchen and the bathrooms in there. And they're more economical than building it literally from ground up.
How many percentage we're talking about? What's the price tag difference?
It'll be at least 30% cheaper.
And then in the long term, the client wouldn't have to pay the utility bills.
Absolutely right. So when we make a net zero home, they literally have no cost of utility, because we are not using gas inside the homes. All the cooking is done with electricity. All the driving is done with an electric car. We provide you with a, driving charging station inside every house. And there's a saving of your energy bill at the end of the day,
But what's the catch?
The catch is that people have to adapt to this thing. People do not like the change. People do not like something new that's just come up in the market. People think that these homes are flimsy, and people think that these homes are made in a factory. They're modular homes. But that aspect of thinking is going to change, because now these materials are so strong that once we demonstrate their building capabilities, we can build 6-story high buildings or even high-rise buildings with the same material right now.
Let's go to the examples of the existing ones around the world and look at those examples and see if that actually makes sense. How did you come around to decide, okay, that would work for whether like California or like whereabouts in the US we can actually use that? Is it geographically dependent on these kind of materials, on which kind of weather they have to be exposed to? How does that work?
I was on a conference call with Dr. Wolfgang Feist in Germany, who is the father of the passive homes. And one of the questions was, where can I build these homes? So we can build these homes in any kind of a climatic condition, They're perfect to be built in the US where the weather is cold, and they're perfect to be built in Arizona, in US again, where the weather is very hot. So either way, you can build these homes in a hot weather climate or the cold weather climate, and they conserve the energy in both the cases,
And it's the same material that's been used for all of these climates.
Yes. Passive homes can be built with lumber also, but we are basically switching over from lumber to, in some cases, steel, which is a really big challenge for me to do that. But going with MGO panels and going with the ResCom material, which is a material that was basically initiated in Australia, because Australia has experienced a lot of fires and very hot climatic condition over there too. So that technology is going to be coming in, and I'm already building a property in US right now with this technology. So the first unit will be done in about 3 to 4 months. My ordering was done in Canada, and the unit's going to be built over there and shipped over to me in California. So this house basically will be net zero home. It'll withstand, you know, high temperatures. It'll be completely fireproof. It'll be waterproof. It'll be termite proof, and it'll be extremely, extremely comfortable, and we'll have a zero PG&E bill for the occupants. This is a full-blown 4-bedroom house, 2,500 square feet, 2-story house, and the cost of this will be about 30% cheaper than the conventional way that we are using for building, because we are saving on the labor cost, not the material cost.
Yeah, let's talk about the MGO panels and what is their environmental footprint?
That's a great question. These panels have been designed and built over a period of time. They have the least amount of carbon footprint as compared to concrete, and these also absorb carbon dioxide. That's the beauty of this material. So this is going to be one of the materials that we're going to use a lot of it in the new construction as we go along from here on, especially in California because of the fires. We are also in the process of developing small units that can be used right now to help out with the homeless population. Once I bring these units into the market, we could just provide these as a simple standalone housing. It can be assembled and disassembled, very easily.
But how long they last?
They have the life of just like a typical home. 50 years to 100 years will be easy, time frame for these homes to last.
And what is the maintenance for them?
We just finish the homes just like any other house. One is finished, you can't tell the difference how this house was done, because it's the interior walls that are different and the roofing material and the structure is different, but it all gets enclosed. You have the same kind of siding on it, you can have a stucco on it, and you can have windows on it, so you will not know the difference from the exterior how this house was built. But it's the interior and the energy efficiency that makes the house very comfortable. And the most important aspect of it is that we are using extremely good heating and cooling system. We are using a heat pump technology, and this heat pump technology heats and cools the house. And all the energy for this is coming from the solar panels. God has given us enough energy. We have enough energy in 1 hour to really take care of all our needs of energy consumption. But it's just a matter of time how we can come up with devices to be able to store it and then use it again. So one of the emerging markets is going to be storage of solar energy. And I think so. Tesla's already shown that they have the Powerwall. You can store the energy. And there are so many other companies which are coming with similar technologies that you can store the energy and use it during the night time or the times when you need it later,
Great. And then if you have like a minute to change someone's mind who's watching this interview about, the use of these kind of houses, what would you say?
I would say that these are going to be the most affordable, comfortable, energy efficient, and homes that people will start living in. They're going to be much more economical than the structures we've been building. They will be fireproof, they'll be termite proof, and they will have the comfort and the clean air quality inside these homes,
Thank you so much for the time, Mohan Mahal. It sounds really interesting, and it was quite an informative conversation. Have a lovely day and stay safe.
Thank you very much.